Dear friends, today I am teaching you metals and non-metals in science. I have given two videos on this chapter already. In those two videos, I have discussed a lot what is metal, what is non-metal, what are the properties of metals, what are the properties of non-metals, and the differences between metals and non-metals. There I discussed about the chemical reactions of metal with water, with oxygen, with acid, etc. Now I want to tell, and you have seen that some of the metals are very reactive and some of the metals are less reactive. When we are seeing the reaction of metals with water, then you might have seen some of the metals are so reactive that even with cold water they can react. But some of the metals, they can react with boiled water. Some of the metals, even in boiled water, do not react. But reacts when? For example, iron. Iron is very less reactive. So what happens? When steam is passed over red hot iron, then only you are getting what? Ferric oxide and hydrogen gas. Like that you are getting. So in this condition, means conditions are changed according to the activities of metals. Dear friends, you see, potassium and sodium, they are highly reactive metals. If you are keeping in open air, then sodium and potassium react so vigorously that they may catch fire. In order to protect them and to prevent accidental fires, you have to keep you have to keep sodium and potassium in kerosene. One question I remember that comes very often: why do you keep why do you keep sodium in kerosene? Why do you keep potassium in kerosene? You have to reply like that. Sodium and potassium, they are very reactive. They react so vigorously, they may catch fire if they are kept in open air. In order to protect them and to prevent accidental fires, sodium and potassium are kept in kerosene. Once you may not remember, but my video you see again and again, the definition or the answer will be learnt also, and I hope instead of learning you try to understand and you may reproduce your answer in your own words. So I hope you understood that answer. Dear friends, now which metal is how much active? That has been arranged in a list. There is a list of metal in science, and the metals are written in the list in the decreasing order of their activities or reactivities. That list is called what? Reactivity series of metal or activity series of metal. So you see, you come to the main question: what is reactivity or activity series of metal? I am writing the answer, and I hope you may be writing also. Question is like that. What is reactivity or activity series of metals? Dear friend, this is question mark. Right. I am writing the answer like that. List of metals list of metals. What type of list? In which metals are written in the decreasing order of their reactivity or activity. So list of metals arranged, a list of metals in which metals are arranged in the decreasing order of their reactivity decreasing order of their reactivity is called decreasing order of their reactivities. The metals in which list of metals in which metals are arranged in the decreasing order of their reactivities is called here you may give comma also, called reactivity series, reactivity or activity series of or activity series of metal. Like that. You see, in every book in this chapter, one list of metals is given, and it is very difficult to learn all the metals accordingly. One new technique I am representing in front of you. If you know that technique, I writing something in the form of sentence. Actually that sentence is meaningless, but every letter written in that sentence is meaningful. And you learn that sentence, and from that sentence you will learn, you will get which metal is how much active. Dear friends, I hope I am writing here and you will understand, or I should rub it. You understood this one, huh? Here you see PSBC, learn like that. PSBC magenta here I am putting here hydrogen, H4 hydrogen. You see PSBC magenta chow. Chow. Here you will be surprised that this sentence has no meaning, but every letter has some meaning. You see, PSBC magenta, H cha. Now, how can you write? How can you extract the meaning? You see, P for potassium. P for potassium. I am writing potassium. K I am writing. S for sodium. So you see, potassium, sodium, barium, barium, Ba for barium. It is calcium. This is magnesium. Mg, magnesium. A for aluminium, Al, aluminium. Z for, here I am writing zinc. I for iron. You may be asking, here is written I, but you are writing Fe. Actually, iron is called ferrum, so I am writing Fe, but it is what? Iron. After that, tin, this is nickel, zinc. Here you see tin. Nickel, it is Ni, nickel. Here is nickel, Ni. And after that you see, this is what? Tin. Tin, T for tin, but we are writing Sn. Symbol is Sn. Sn for tin, it comes. L for lead, but we are writing what? Pb. Pb is the symbol of tin. Here this comes as hydrogen. Hydrogen is non-metal, but it comes in the activity series of metals because sometimes it behaves just like metal also. After that, let it be hydrogen. H. After this is not metal, non-metal it is. This is copper. Copper. Cu. This is mercury, Hg, hydrogenum. You know that scientific name of hydrogen is mercury is what? Hydrogenum. That is why H comes. This is different. Hydrogen. And this is hydrogenum for mercury. This is mercury. This you may write Hg. Actually you have to write Hg, mercury. Dear friends, after that it comes what? This is argentum. Argentum for what? Silver. Argentum, easy. After that it comes for what? Aurum. Aurum for gold. And this is in the last word, platinum, Pt. But in your book, not these many metals are given. So it is very easy for you to represent the series. You see how can you write? You will write potassium by seeing this. Sodium, barium. Barium is not mentioned in your book. You see in the page. But I have written calcium, magnesium, aluminium. After that zinc, Zn. After that ferrum. After that nickel. Ferrum is what? That is iron, nickel. After that SN tin. After that lead Pb. After that hydrogen I am writing in the bracket because it is non-metal. Then you see copper. Then you see hydrogenum, mercury Hg. Then you see Ag. Then you see aurum. Ag for what? Ag is argentum, that is silver, and Au aurum, and after that in the last Pt. So really, if you learn this like sentence, it will be easier for you to know the activity series of metal. Once you tell with me PSBC Untitled Chapter, and every letter I have written what should be. You see P4 potassium. Potassium you see. Actually you may be surprised, potassium should be starting with P. No, potassium is called kalium. That is why K we are writing. Sodium, barium, calcium, magnesium, aluminium, zinc, iron. It starts from I, but iron is called ferrum, so we have written Fe. Nickel, Ni. Then T for what? Tin. Tin is written as Sn. Lead, Pb. Hydrogen, that is non-metal, but it is included. And one thing I am telling you, metals actually react with dilute acid to produce hydrogen gas. But what happened? The metals which are before hydrogen in the activity series, only those metals will react with dilute acid to produce hydrogen gas. But you see some of the metals are coming after hydrogen in the activity series. You see copper came after hydrogen. So copper cannot react with dilute acid to produce hydrogen gas. Here you see hydrogenum, that is mercury. Mercury can not react with dilute acid to produce what? Hydrogen gas. After that you come to know argentum, that is silver. Argentum means what? Silver. Aurum means what? Gold. Platinum. So in this way, these metals which come after hydrogen in the activity series will not react with dilute acid to produce hydrogen gas. So from this sentence without meaning, why I am telling this is a kind of sentence but it doesn't have the meaning. The meaning is lying with the every letter. Here you see. So once you try, you will learn PSBC Untitled Chapter, and everything I have written here what happens. Dear friends, so activity series of metal or reactivity series of metal you know very nicely, and you can learn by this process also. Now I am proceeding a little bit. Here you see how do metals and non-metals react? Why do metal or non-metal react? Here you see. In class 9, your teacher might have explained nicely. Every matter, whatever matter is there, they are made of what? Every matter is made of what? They are made of minute particles, or every matter is made of what? Minute particle. That is called atom. Atom is almost spherical. And in the atom what happens? Do you understand? You see a spherical, of course it is in the center you are getting. Center of the atom is called what? Nucleus. And in the nucleus you are getting what? Proton and neutron. Neutrons are the neutral particles and protons are positively charged particles. Dear friends, after that what happened? Around the nucleus there are energy level, that circular orbits are there, they are called energy level. And in these energy levels, electrons are revolving. You know that every atom contains what? Proton, neutron and electrons. Neutrons, all that is neutral particle, protons, positively charged particle, and electrons are the negatively charged particle. Electrons you are getting in the first orbit, second orbit, or in the circular path, or in the energy level, a path for the electrons. So these are called what? Energy level, or sometimes we are telling our orbitals also. Here you see in the first orbit there are 2 electrons. In the second orbit there are 8 electrons. 8 electrons in the second orbit you see. And in the third orbit there are, if it is outermost orbit, then only it would contain 8 electrons. I am not going into detail. So atoms are having electron, protons and neutrons. Dear friends, now I am not going to teach you electronic configuration. Electronic configuration is what? Distribution of electrons in the different energy level around the nucleus of an atom is called electronic configuration actually. My dear friends, if I am going there, it will take a lot of time. I have to explain and finish the chapter also. But little bit knowledge I am giving. Valence electrons means, do you understand? Valence electron, the electrons present in the outermost cell or outermost energy level of an atom are called valence electrons. You see, in the case of sodium, what happens? Suppose it is sodium atom, then you will get 1 electron in the outermost orbit, and electronic configuration is sodium is what? 2, 8 and 1. So you see 2, 8 to 10 and 1, 11. Atomic number of sodium is 11. That you might have heard in class 10. So you see, this is called what? Valence electron. This is called valence electron. So all the metals have the valence electrons, either 1 or 2 or 3. But whatever non-metals are there, when you are going to arrange the electrons in their cells or in the orbitals or in the energy levels, you will get in the valence cell number of electrons may be 4, 5, 6, 7 like that. And so the valences are called like that. Suppose 2 valence electrons are there in the outermost cell, then you will tell valence is 2. Suppose 7 electrons are there, then you cannot call 7 valence. 8 minus 7, 1 valence. But number of valence electron will be 7. Like that we are getting valency. Now, I want to tell, you might have heard about the inert elements. All the inert elements have 8 electrons in their outermost orbit, except helium. Although helium is inert element, but it has only 2 electrons in the outermost orbit. So rest all the inert element has valence electron 8. You see, now whatever element is there, every element has tendency to keep the number of electrons in the outermost orbit 8 to gain the electronic configuration of its nearest inert element. In order to that, the metals do what? Metals donate electrons and non-metal gains non-metals gain electrons. In donating and gaining, they are forming the positive and negative ions, and they will meet together, and that is why the reaction occurs. Two inert elements, suppose you are keeping, none of them gain or donate, so they will not react. Only the reaction occurs when one donate, one gain, or sometimes non-metal react when electrons are shared. That is different. Here you see one more thing I want to show you. How do sodium and chlorine react? Here you see sodium. Sodium has you see sodium, this is, and chlorine here. Why they react? You see electronic configuration of sodium is what? 2, 8, 1. When you are drawing the atomic structure, in the first cell you are getting 2 electrons, in the second cell you are getting 8 electrons, and in the third cell, outermost cell, you are getting 1 electron. So valence electron is 1. But here in the case of chlorine, so valence electron only I am writing here, valence electron, dot I am giving. Here in the case of chlorine, what happens? Atomic number of chlorine is what? 17, you remember. So when you are going to distribute the electrons, here you see 2, 8 and 7 electrons are in the cells. First cell contains 2 electrons, second cell contains 8 electrons, and third cell, that is the outermost cell in the case of chlorine, that contains 7 electrons. How can you write these 7 electrons? You see here, first of all you write 1 electron here, all around. Now what happens? 2 electrons, 2 electrons, 2 electrons. So you see 2, 2, 4, 2, 6 and 1, 7 electrons. 7 electrons are there in the outermost orbit. My dear students, here if sodium loses 1 electron, suppose sodium loses 1 electron, then what happens? Do you understand? 8 electrons will be in the outermost orbit, so sodium will be stable. So it will try to lose electrons. Or you think, suppose sodium going to gain the electron, then sodium will have to gain 7 more electrons. And if it is going to lose electron, then sodium will have to lose only 1 electron. So losing is easier. So sodium is a metal, it is losing electron. Here chlorine is doing what? Do you understand? Chlorine, if it is going to lose, then it will have to lose 7 electrons, then only it will have 8 electrons in the outermost orbit. So better chlorine does what? Do you understand? It gains 1 more electron from metals and it becomes stable. So you see sodium will lose electron like that, and you know whenever an element loses electron, then it becomes positively charged, and whenever an element gains electron, then it becomes what? Negatively charged. Here you see sodium loses 1 electron, so it becomes what? It becomes positively charged. 1 charge has gone. Now what happens? Do you understand? Here actually chlorine gains 1 electrons. This will lose and this will gain. So ultimately what will happen? Chlorine becomes here you see when it loses electron means what? 1 electron has gone. So it becomes what? 2, 8. Now it gains 1 electron from where? From sodium, because sodium will lose, so it will gain. So after gaining, it was 7. Now it becomes what? 2, 8, 8. So it became what? Stable. Now all together you see here you see 8 electrons you are getting, but after gaining electrons it becomes what? Negative. So it is losing and it is gaining. Now these two, how they do react, do you understand? So shortly I have explained like that, but really it is like that. Sodium 1, 2, 8 and 1, and here side by side I am writing chlorine. Here you see chlorine. From here 1 electron is donated, so chlorine becomes like that. Now here what happens, do you understand? Sodium became positively ions and chlorine becomes sodium became positively ion, because 1 electron is losing, and chlorine, as it has now 8 electrons here, by gaining 1 more electron, so it became what? It became negatively charged. So negatively and positively they combine together and they are forming what? Sodium chloride. So in this way sodium chloride is formed. My dear students, always it occurs that metals lose electrons and non-metal gains non-metal gain electrons to form the compounds, and in this way compound is called sodium chloride. Now sometime question may be asked, how is you show the formation of sodium chloride? Then like that you will write and explain is what? Only you write the electronic structure, or you can write as I am writing, and you write, you will get full marks. Thank you my dear student. This video was very lengthy, so I'll discuss more thing in the next video. Thank you.